Boosting. If bagging and random forest focused on creating independent learners, often in parallel, mainly to reduce variance, how does boosting differ conceptually?
Boosting takes a fundamentally different approach. It's an adaptive, sequential technique, and its core philosophy is focused primarily on reducing bias rather than just variance, although it often reduces variance too. So instead of training lots of parallel, complex trees independently, like in bagging or random forest, boosting fits trees sequentially, one after the other. And the key difference, the core idea, is that it adaptively weights the observations in the training set for each subsequent learner.
Adaptively weights. That sounds like some kind of continuous error correction process. How does that sequential weighting work in practice? What's it actually doing?
It's essentially an iterative focusing mechanism. You grow the first tree on the original data, then you look at where that first tree made mistakes. When you go to grow the second tree, the algorithm intentionally focuses more intensely on the data points that were misclassified or had large errors from the preceding tree or the combination of all preceding trees. Those difficult points, the ones the model got wrong, are assigned higher weights. This forces the next tree being built to pay closer attention to them and try harder to get them right. If you look at more advanced versions like gradient boosting, the subsequent trees aren't even trying to predict the original outcome directly. Instead, they're trained to predict the error, the difference between the actual dollars and the prediction made by the current ensemble up to that point.
Wow, okay, that is a fundamental difference. So bagging is like gathering this massive committee where everyone gets trained on slightly different data and then they all vote equally. Boosting sounds more like an apprenticeship, where the master constantly points out the apprentice's mistakes from the last attempt, forcing them to specifically learn from those past errors in the next round.
That's a fantastic analogy. It really captures that sequential, error-correcting nature. And here's another structural detail that highlights the bias reduction focus.